All right, folks, we're going to start with this panel, Marine Tech. Brett Phaneuf, facilitator, Marine Tech. Brett Phaneuf is the founder and chief executive of Submergence Group LLC, M-Subs Ltd, based in the UK. Through his office in the UK, he oversees the design and production of manned and unmanned underwater vehicle systems. A serial entrepreneur, Mr. Phaneuf, it's like you're under indictment,
it's my dad.
has recently turned his attention to machine learning and artificial intelligence. A new company, Marine AI, has spun out of M-Subs Ltd. with the goal of creating cognitive AI to enhance maritime capabilities by drawing on decades of experience in manned and unmanned marine vehicle design, manufacturing, and operations. Coupled with vast experience in automation, autonomous system software architecture, and computer vision expertise, Brett is also, now we're back to Brett, huh? Brett is also one of the 3 founding members of the Promare, a nonprofit 501c3 public charity founded in 2001 to promote marine exploration throughout the world. And some of you may know him best as being the father of the MAS, the Mayflower autonomous ship that sailed itself here across the open ocean using IBM technology and solar power. Ladies and gentlemen, the most interesting man in the world, Mr. Brett Phaneuf.
Well, I kind of want to clap for that introduction. That was, thank you very much.
I helped you write that.
I felt like we were in a Dos Equis commercial.
I know, the most interesting man in the ocean. But that was an appropriate introduction in one way, Stephen, which is you talked about this, and that sort of is an interesting thing to touch on, and it's sort of what we're going to focus on with marine technology today, because I'd say in the last 25 or so years, these folks may agree or disagree with me, we've seen nothing short of a revolution in the production and the sophistication of technology that goes out in the ocean. And a lot of it has to do with data. And it's all driven around trying to understand how the ocean works and how the planetary dynamic works. If you understand the ocean, you'll probably understand the planet. It's the most sophisticated thing we have to deal with. And we're very, very, very far away from a comprehensive understanding. But in terms of data, the first one of these really was 2002. And I think it's important to note that this device, in fact, the one in 2002, had more processing power than all of the Atlas missions to the moon combined and all the space shuttle missions ever flown. You could do all of it with this. And we have it at our fingertips every day. But also in 2002, something really interesting happened. We produced, as a species, more data than had ever been produced in aggregate for the entire history of the planet. And then in 2003, we doubled that again. And that's continued. Now, 90% of that is selfies. Probably, it's a guess. But it's data nonetheless. And what we've got now is an incredible revolution in microelectronics, so low power, so size, weight, and power, low swap, they call it, that can be deployed on the edge in devices in the ocean, devices in space. Starlink is a fantastic example, and an enabling technology to collect data. But we find ourselves in a data glut. We have so much. We're struggling to produce information that people can digest and that's actionable. And we're barely able now to start processing data and information in such a way that we can holistically understand the questions we're posing about how the Earth works. And so AI is driving that forward. It's making it possible, but it's also moving the ability to engage in science for the average person further away. And ironically, the need to use artificial intelligence to process vast amounts of data into information is incredibly energy demanding. In fact, in the next 5 years, we will outstrip our production of energy by a factor of 2, and most of that will be driven by the need for data servers to run AI algorithms. So we're going to pollute in order to understand why we're polluting. This is a serious problem. So we're on the threshold of another step change. So we've realized that just vast amounts of data, vast amounts of information produced from it can't be understood by a vast amount of people, and it's not answering the fundamental questions yet. So there's another revolution that's just in front of us. And the people on the panel today all work in the ocean, from research to the commercial sector, the corporate sector, producing the instruments that create this data, and then the regulatory section that have to figure out how to balance the needs of the public and public safety. So I think I'll start, if that's all right, by posing a question to Lena, and if you would introduce yourself, and maybe you could comment on how you deal with data, because you're out there at the aquarium, you're actively collecting data, and you have to deal with that and build that into a plan of action for how you manage or advise the government and people on how to manage the ocean.
Yeah. Hi, I'm Lena Weiss. I'm a program manager at the Balanced Blue Lab, which Vicki mentioned earlier. So our program specifically is really focused on responsible ocean use and how we can drive innovators and industries towards practices that are more environmentally responsible. Our scientists as a whole are spending a lot of time trying to figure out animal behavior. So why are right whales spending more time in Canada? Or this year, they've spent more time in the Gulf of Maine. Why are they doing that?
Is it free healthcare?
It could be.
No, I'm sorry.
It's definitely not because, so to be able to understand that, or to be able to understand how animals might interact with offshore wind turbines or with offshore aquaculture installations, we need data, and we need oceanographic data because that underpins everything. If right whales are moving because their food is changing, that's ultimately driven by environmental variables. So some of that data we're collecting ourselves on sensors. And an example that's been in the news recently is we have these little buoys all over Boston Harbor to look for juvenile sand tiger sharks. So those are data arrays that we've put out there ourselves, but we rely on a large part on open source oceanographic data that the government is collecting with these buoys that are up and down the coast. We are very interested in using, new innovative technologies that are collecting this kind of data at a high scale, at low cost. A big issue for us is we rely on publishing our findings. We need everything to be open source. We can't really have too many secrets or sort of obfuscations. Obfuscations. We need to know how the sausage is made, essentially, to be able to publish. So a big barrier for us in sort of adopting some of these new models and things that are coming out is that there's a pay-to-play model in some of these, and that does prevent us from adopting them in some cases. There are a lot of great companies out there that have open source models or models that are more tailored to scientific users. Yeah. So I would just say if you're out there as a technologist, as an innovator, and scientists are a potential customer, these are conversations that you have to have when you're looking at use cases and upfront, so you understand what our limitations or hesitations might be. I would say overall we're not hesitant, we're all in. We want there to be faster, more reliable data. We want to be able to make faster decisions. We want to be able to warn people if there's something that's going to be negatively impacting marine mammals or turtles out there. So,
well, the economic pressure is kind of interesting because in my field, the preponderance of the money, whether people know this or not, to develop technology for the ocean comes from defense. Yeah. And so Arnar Steingrimsson works at Teledyne, and he's been developing autonomous technologies now for ocean exploration for 30 years. Have I dated you? 25 years? How many years?
25.
25. And they've just launched a fantastic new project at the bleeding edge of technology, an underwater glider. So it's like an underwater airplane that uses gravity and buoyancy to propel itself. And they launched it Friday to circumnavigate the globe. Is that right?
Yeah, that's right. Sentinel mission.
Yep. So, and what's interesting is that technology or similar technology to it, at any given moment, there's 3,000 to 4,000 of those things in the ocean constantly producing data. But I'm curious what your position is on the economics of developing this advanced technology.
Yeah, and if I can come in on a couple of things my colleague said here. So, like I said, Arnar Steingrimsson, I handle largely the commercial aspect, so I'm representing industry in a sense, right? And how we handle data, I don't want to say it flippantly, but it's more our customers handle that data. We're not really so much in the business of handling the data per se, but What we have to do from the industry side is make it actionable data, relevant data that you can quickly do something with, whether you're trying to find marine mammals or if you're trying to find submarines. It's still the same kind of concept. You're getting some data input. You have to have increased autonomy on the robot itself so that it can do something with that data. You can have perhaps all the data at the end of a mission, but really robots, when they're out doing their thing subsurface, you're getting some snippets back. You're not getting every bit of that large data. I think another thing that comes up a lot, and you kind of hit on this, and a lot of this work is on the defense sector, but even on the commercial side, data security is a massive consideration. So that we work a lot on those kinds of things, making sure that we have secure systems, making sure we have actionable data, and then we also work with a lot of, we build the kind of the robotic platforms themselves. We also work with a lot of partners that provide that autonomy, provide that specialization around data. And there's even folks like here in Plymouth, like Greensea, that we've worked with on that regard. So I think what you said, there's a lot of layers to data that we have to keep in mind.
Would you say that in the last section, which is a hard act to follow, with Bill Nye, he was fantastic, a lot of mentions about the space program, and of course, space-based technology for ocean science, climate science, is profound. It cannot be, we can't understand the planet without it. But I think that the defense industry that drove the space industry, that drove the creation of a space industry, that drove us to the moon, and I know they talked about that in the last section. People ask, well, what did I ever get from sending guys to the moon? And my answer is, well, microwaves, if you like microwave popcorn. And pretty much almost all the modern technology in the late 20th century was a direct outgrowth of the moonshot, because the investment was massive into generating the technology to be able to do that. And I would say that, and I wonder if you agree, that for the research side, they're the same sort of beneficiaries, the general public, in the creation of these incredibly sophisticated technologies that would probably otherwise be unaffordable, which is sort of a sad commentary that, in one hand, the money to produce the device that makes the data that helps us understand how to save the planet is provided by the people also funding weapons programs that could destroy the entire planet.
Yeah.
So there's a lot of irony there. And it can't, I don't know what you think about that. I think about that a lot, actually, in what I do. Sorry, did I say too much? I stole it from you there.
Yeah, sure. I mean, if that's to me, obviously the defense sector is a huge component of what we and other, manufacturers, robotics manufacture in the maritime space. But largely, if you look at this space, all of this technology came out of, mostly all the robotic platforms that we make and our competitors make came out of academia. They came out of some research requirement to be able to do something. And a lot of that then technology is transferred over defense. But I think there's some positive aspects of that symbiotic relationship as well, where defense also pays for a lot of R&D that in turn then rolls back into the scientific sector. So
well, the GLIDER program is a direct outgrowth of a university research program, isn't it?
It comes out of HUI and Doug Webb and all that. So that Argo program, the AUVs that we do up in Iceland, that we've worked with you funding Viking ships in Norway 20 years ago.
That's right. We found almost 100 perfectly preserved middle-aged ships that he brought an incredible piece of technology to a lake in Norway, and nothing degrades there. So there's all these shipwrecks just sitting there, hundreds of them. Perfect. It's quite strange, actually. But maybe, Arnar, you could tell us a little bit about the Sentinel program, because that is fascinating.
Yeah, so
do you mind?
No.
Put them on the spot.
So the Sentinel program, it's a subsea glider, as Brett mentioned, uses a buoyancy engine expelling a liquid kind of in and out and making itself positively or negatively buoyant. So it's kind of gliding, doing yaw patterns subsea. While it's subsea, it's gathering oceanographic data like CT, so temperature, salinity, it can be doing current profiling, whatever kind of oceanographic sensors that you have on there. But this, the Sentinel program is something that we're doing in conjunction with Rutgers University. It's a program that one of our close academic collaborators, where we previously launched vehicles across the Atlantic that took, I think, about 9 months to cross the Atlantic. And the idea came from that, working with academia, working with folks on the governmental side as well. You know, wouldn't it be cool if we could take this robot and make it circumnavigate the globe? There'll be a few stops that will re-battery, and gliders move very slow. So this is a multi-year program. Over the next 4 years, we'll be circumnavigating. And this is, you know, technology here developed in Massachusetts. So we're down on the Cape in Falmouth, and we just launched this platform on Friday. It was a bit in the news. You may have seen some coverage, and hopefully we didn't surprise you guys too much.
No one's complaining.
And maybe we can, Mason, you can introduce yourself and talk about this a little, because you're seeing the proliferation of uncrewed and autonomous systems at sea, both on the surface and subsurface, and you have kind of an onerous task.
I do.
I would say.
Yeah, thanks, Brett. Mason Wilcox. I'm the officer in charge of marine inspection for the Coast Guard. I cover all of Rhode Island, Southeast Mass, Cape and Islands. And you know, I met Brett going on 5 years ago now, when I got this article about this crazy guy sending an autonomous ship across the Atlantic Ocean, and I met Brett shortly thereafter. And we were, you know, struggling within the Coast Guard. The regulations say that every vessel should have a proper lookout by sight and hearing. And you know, our attorneys, and you know, I want to apologize to any attorneys in the room right now. A lot of them just didn't understand, like, these rules were written in the 70s, early 70s, and you know, technology has really progressed beyond the 70s, and you know, we have to kind of live with the ages. So we worked very closely, like, how can we allow innovation and technology to grow without stifling with our outdated rules. And you know, we find balances. I think Brett was one of the first companies to really be regulated with the Mayflower. Like, how can we get it here? You know, there's some people within the Coast Guard that think every autonomous vessel is, you know, the next R2-D2 and is going to kill the world at a Terminator, the movie. Where, you know, I'm on the other hand, it's like, hey, this stuff is cool. We can start moving stuff quick. You know, we don't have to pay. The most expensive part of a ship is the crew. And, you know, we have to find a balance. I don't need a bunch of boats out there without people, you know, hitting people in the water. And, you know, obviously the companies don't want blood on the bow of their boats. So there's a very delicate balance that we have to work on.
But you also, as the Coast Guard, are first movers in adopting autonomous technology to augment the fleet for national security interests as well. So you're both your regulator and your user.
Yeah, and we have that internal struggle sometimes between our R&D folks that are, you know, working on systems that are outside of my, you know, world within the Coast Guard, that are looking for the, you know, the criminals on the water, the people running drugs, the people running human smuggling. You know, righteous to use every technology to stop that, but at the same time, you know, we struggle with even the Navy most of the time up here, and even our R&D center in New London. Like, hey guys, there's certain rules that we make industry follow. Can you please play along, at least during testing, because we have to share the waterway. And part of my job is to be, you know, the traffic manager of the waterway and enforce the COLREGs, you know, the rules for collision at sea, or prevention of collision at sea, actually. So we all have to play friendly. There's only one ocean for us to play on. So.
That's true. So I'm not sure where to take it next. You know, I think the deployment of technology is only increasing, but I'm a little bit concerned about, probably my biggest concern with the development of advanced technologies is we're sort of definitely reaching a plateau in terms of the ability to handle the data and the information we have. We're reaching a cost plateau, as you alluded to. You can't afford to use some of the very, very sophisticated tools that you might want to. And of course, those companies developing them are trying to figure out through venture capital plays how to fund them, and that may or may not necessarily be good. But we're definitely reaching sort of a plateau, and I'm wondering where you think the future, each of you thinks, sort of what you see as the next revolution in our ability to collect data, create information, and manage the ocean more effectively, both from a purely scientific perspective and maybe from an economic perspective as well.
Yeah, I think we're definitely seeing there's a ton of people right now creating sensors and gliders and things that can collect data. I think the next hurdle is, can all this data play together? Can it be uploaded to the same system and used by the same system? Can the government use all this data? And then also, how can this help us make decisions better? So if we're saying that we want to be able to make decisions faster, our management systems have to be able to deal with that. And a lot of times, I think less so at the local level, but definitely state, federal, our systems are set up to be slow, to include a lot of time for thought and stakeholder input, and that is very important. That's not necessarily set up to make lightning fast decisions because we've gotten, we have all these sensors out there and we're getting all this input. So turning it around, and we talked about this on Friday, in a way that makes sense, that isn't over alarmist, where the data is being interpreted before it is being utilized. I think that's very important.
Right, and as I said to you, I've been in the United Kingdom for 15 years, and anytime it gets over 79 degrees there, they refer to that as a heat-pocalypse. Right, so there's a lot of apocalypses that we have to avoid, and I find it interesting, so that we're creating data at not an alarming, but an incredible rate.
Yes.
And it takes us a long time not just to process it, but that's accelerating. But then we don't necessarily know how to regulate with that data. And then what I find fascinating is the processes in the ocean are remarkably slow.
Yes.
And people don't understand that. So, for example, you hear a lot about the Gulf Stream. And as the water warms, the Gulf Stream may stop, right? And when people say that, they mean, maybe in the next 3,000 to 5,000 years, maybe. And if you think about the water that's coming up and warming our coast, when it gets up into the high Arctic, it sinks. And then there's a countercurrent, and it goes all the way around, and it goes down the bottom of South America, and it ends up upwelling off Papua New Guinea in the Far East, or in the West Pacific. That takes a little over 1,000 years. So when you measure sea surface temperature, or you measure water upwelling, and you say, oh my God, it's warmer than we expected, the temperature you're measuring might be from 1,000 years ago. And it's very hard as humans to comprehend that and build that into models that are actionable within our lifetime. So I'm not to say we shouldn't think about it.
No,
But
I think it's a very valid point, and I think what we're seeing, I don't know if Josh is still here, but what Coastal Measures is doing is sort of taking that middle step of let's visualize this data better so that it's more understandable to people that aren't oceanographers, that aren't engineers, and then maybe we can use it in better ways. And I think a lot of the things that we're seeing now that are sort of more on the early adopter edge are individuals who have a little bit more comfortability, being able to, comfortably make that next step. So how do we sort of widen that aperture a little bit so that everyone feels more comfortable being able to see and interpret data and knowing what to do with it and knowing if it's worth doing something or not.
Running around screaming.
Right.
Yeah. Arnaud, what do you think the next step in the development? Where do you see, from a commercial perspective, corporate perspective, what's the next big leap in the technological evolution that you're seeing for deploying sensors at sea?
Well, yeah, there's a few things I kind of want to, there's all great points that were just mentioned. I think from a technology or manufacturer perspective, what's next? I think we're constantly pushing the boundary and capabilities of these unmanned systems, right? So there's been incredible developments over the past, we talked about 20 years ago or whatever it was, working together, the size, weight, power of certain sensors, so you have much more capable sensors which also typically come with a power hit and much more data hit also. So a little bit of a two-edged, a double-edged sword there. And endurances, things like the Sentinel mission that we just talked about, being able to do something on an oceanographic type scale. Getting back on the data thing, and just from a manufacturer's perspective, what's kind of some challenges we deal with there is the data standards, right? So everybody, and because
You mentioned that.
we don't work just here in the U.S. We sell our equipment to most NATO nations. We sell internationally. Depends on what the market is and what the application. We have a lot of global scientific users. We have global military users. Everybody wants their data in some format or another to work in their command and control systems, to work in their post-mission analysis software systems. And that's where I think the regulatory side, to some extent, can really help with some data commonality. So things like we're doing on the Janus, which is more of a NATO thing, I get, but some commonality just in the acoustic modem communication standards, right?
Yeah.
Common data standards would benefit everyone, would benefit the users, manufacturers, would make things a lot simpler. So I think, yeah, in a nutshell, where we're going, a lot more capability, better sensors, more autonomous behaviors, more, when I started out doing this, it was a lot of these products, like I said, come out of academia. So it's some PhD designing a tool for another PhD. That's not really how a lot of these things are used, right? So they got to be more intuitive. They got to be like your example of the phone. They got to be easy to use, and just kind of, you don't really care so much about the platform. The platform does something. It's ultimately the data that you get off it, right? So the platform's able to give you data that you couldn't otherwise get, but it's all about the data. So things that facilitate that rapid, actionable data in whatever environment that you want to work, I think is kind of where we're going.
Well, I have a follow-up question for you then, and it's more around cost.
Mm-hmm.
So the cost of data per unit has gone through the floor
Mm-hmm.
because there's so much of it that we can gather so much more easily now. And there's a lot of open source data from NASA and from NOAA and others. Do you see the cost of devices diminishing, or do you see that the cost adjusted for real world, real year dollars is about stable because you're increasing capability every year, even if the form factor is the same? And then do you see manufacturing in the U.S.? Is that an international thing? Do you do it mostly in the United States? Do you think there's a decent future for manufacturing domestically? And, I think one of the things I'll talk about tomorrow with the session on jobs that we're going to do with young people is, well, how do they get involved with ocean tech companies? The aquarium is fantastic. You have a lot of interns.
Yes.
And a lot of apprentices, but how do they get involved with companies like Teledyne? And so that's a bunch of questions all in one. Apologies.
Yeah, and hopefully I'll remember most of them, but it really, Brett, it depends on what segment of the industry you're looking at, right? You're saying, is data cost going down? Well, it depends on what you're doing. If you're doing oceanographic type Argo type float data, yeah, data per profile is going down. If you need to find an adversary submarine, it doesn't really matter what the cost of that data is, right? So it's a criticality of the data, the importance of the data. If you're running mine warfare operations and you got to find mines before you go do something, again, it doesn't really matter how much it costs. It's going to cost less than losing a ship or losing people. And so it kind of depends. And then, maybe take it back to the science side. What we do, and most of kind of our colleagues and others in this industry here in Massachusetts, certainly, we're more on the highly kind of engineered side of that. There's a lot of, some of the stuff that's becoming commoditized, right? Lower end technology, you see all that from, China, other places have advanced a lot of that, but we tend to focus more on the higher end, more kind of difficult problems, which you talked about space, it's getting to that kind of level of engineering, as you know.
I actually think it's beyond space, right? So I think Bill brought that up today, Bill Nye, because was it cold, crushing, and corrosive? You know, I often tell people that with submarines in particular, we're building underwater spaceships, which is much harder than just plain spaceships.
Yeah.
And that the one advantage you have if you want to get involved in really profoundly interesting technology, and you're interested in space, for example, I tell people often, young people, is that, well, you are in space, on a planet, flying around through space, so you are in space, check, and if you're interested in exploration, unlike outer space, the ocean is readily accessible. You can literally walk to the edge of it and start doing science. It's not that hard. A microscope and a bucket will get you going. So yeah, it is much more challenging. So Mason, I'm curious from your perspective where you think the Coast Guard's going and how you see collaborations with universities,
Tell
with
us all the
corporations.
government secrets.
All the government
Tell us
secrets.
everything, yes.
We're closed
And
right
where,
now.
where do you see the Coast Guard going with advanced technologies like autonomous vessels, and then how do you view sort of partnerships with academic organizations and corporate partners?
So,
That's not too much.
no, I even wrote down some notes, so I don't forget
All right.
this time. Yeah. So, I mean, the last time our rules of the road were updated was 2001. And that was, you know, at the international level, the United Nations. And that was for wing and ground craft. And how many WIGs do we have out there right now? None. And there's one prototype company operating, right? It's going to take a lot to update the rules so we can all, you know, drive on the water, you know, and follow the same set of rules. But until then, you know, we have to keep learning about, you know, what it takes to operate uncrewed vessels and how those interactions work with crewed vessels. I would argue, in Mason's opinion, not the Coast Guard's, the attorneys get mad when I say this, but they're not here right now. I would argue that the technology today on most uncrewed craft is far superior than, you know, that guy that's on his sailboat sailing single-handed from Miami to Maine and, you know, takes a nap every couple hours, you know. And obviously the speed of autonomous craft right now operating are a lot slower than a lot of the other boats out there. But, you know, we need to learn from both the successes and the failures and how we can incorporate, you know, these technologies into our current, you know, waterways. I think long term, you know, right now we're in that walk phase as far as we're concerned. You know, looking at, you know, data collection is the primary use of uncrewed craft, whether it's bathymetry, oceanographic data, even, you know, air monitoring. I think one day we're going to see some sort of freight service, even if it's a crew that rides a ship out to 12 miles and then lets it go across the ocean. A new crew takes it on and brings it to the dock. I think we're going to start seeing more assistance towing, search and rescue capabilities, uncrewed, you know, drop it out of a helicopter and let it go help somebody. Passenger service, you know, I personally, I don't see that happening anytime soon. Someone's got to be there to help the people that in case there is an issue. But I don't know, maybe we will someday. But, you know, I think the best is we need to learn from everything right now in order to have a good path forward to the future.
Do you mind if I ask a question?
Go nuts.
Okay. Watch out.
All right.
At least in my mind or my experience of this, is that the pace of the way that a technology company is developed and grows is very fast, and they have a very narrow window where that's it, it's live or die. It's, you know, a year or 2 years, really. Do you think that in of itself is incongruous with, like, being able to be used in some of these applications?
So,
Like, will it ever survive to and live to that stand?
so
Sorry.
No. Like, I'm thinking back. Like, most of our rules are written in blood. So when the Titanic sank, it took how many years for us to require 100% life saving on ships? Several years. And that was, you know, a lot of people that had to die. You know, when 9/11 happened and we came out with the Marine Transportation Security Act, that took 2 years. And a lot of people had to die for that. You know, all these rules, I don't want to say all of them, majority of our rules are written in blood, just, you know, reactionary how we work. With all of that behind us, it's important to work with the regulators, and I would say the Coast Guard's a little bit more friendly than some other government agencies. You can put that on the record. We try to find a way to say yes. That's always been my mantra personally, wherever I've been stationed, to not stifle innovation. I keep saying that. That's the most important thing in my mind. So we can learn. There's certain things we're not going to be able to get beyond because they're U.S. code, they're law, and it requires congressional change. But I think baby steps, we're going to get there.
Certainly not this fall, then.
No. But I think the best place to start with all of this is the world that we're in right now is all the data collection. If the boat sinks full of data, no one dies, right? So it's a great place to start.
If I can come on a couple of things there.
Yep.
I think we also, from a manufacturer perspective, I mean, we get a lot of these regulatory things, but not so much, from the coal regs and as a whole separate kind of thing, but all these mill standards, stain ags,
Yep.
all the oil and gas, safety,
Yep.
Which, I mean, to some extent, they slow you down. But the flip side of that is obviously some of the tragedies that we've seen in other areas, right? So if you don't have that kind of regulation, exactly Titanic, but we've had recent ones with manned submersibles and things, that I do think it does make it difficult though for a small startup to come into this sector and to rapidly get something out because there's just so much stuff that you
Usually I find with small startups, they just are blissfully ignorant of the regulatory frameworks.
Oh, I find new companies every day.
Yeah.
But we try to hey, let's work together, versus shut it down.
Well, so I appreciate you guys coming. We've got about a little less than 10 minutes. 5 minutes, whatever. You're not the boss of me. Does anybody have any questions you'd like to ask me or anybody on the panel? Hopefully we didn't bore you too much with our discussion about data and technology. Please.
So actually, my friend was a marine inspector up here for a while. But how is it that, with working with the government, obviously, with the shutdown, are you having any issues, with regulations and policy as you come through this, working federally, with the ups and downs that are going on? Are you guys seeing a lot of issues with different administration and with the things going on in the world right now?
So I can just, for a second, I can say.
Go ahead.
I can say this. Up until now, it's been great, but they just missed 2 payments. So I'm annoyed. But anyway.
Oh, paying you? Yeah, I got my paycheck, but maybe not
My
next
company
week.
didn't get paid.
Yeah. So, us uniformed people are at work. We have to continue to do our congressionally mandated missions, so we're still doing our inspections. We're still doing our investigations. Our extracurriculars, travel for conferences. I'm not here right now. Those are not permitted because there's no funds to do it. All of my civilians are on furlough, so I've picked, my uniform guys have picked up the fishing fleet. New Bedford, one of the U.S.'s largest fishing port, and I have to have my active duty guys doubling down on both our congressionally mandated mission of, ship inspections and all of that, and also do the fishing fleet, because I'm not going to tell the fishing industry they can't go out. I think my building will probably be burned down.
I wonder how autonomous technology in the future, what happens to an autonomous robot at sea when there's a government shutdown? I guess it just continues to be that.
Keeps going. Yeah, I guess
It
so.
doesn't get paid.
Hey, that's not my department.
They're going to put us all out of jobs.
We just continue working, as we did last time too.
Anybody else? That's a heady topic.
Yeah. We obviously work a lot with the government in terms of our scientific collaborations that are very long-term. We also receive a substantial amount of federal funding. I think since the pandemic, we've really focused on diversifying our sources of funding, and that's really helped us out. And like Vicki mentioned, my program specifically is lucky enough to have received a really substantial gift from a private family foundation that will kind of carry us through for the next 5 years, and we're actually able to grow our work, which is weird to sort of be in a little bit of like happy good news in all of this. So I think there
That's great.
is interest in technology and you know, growing this space, so I think that's good.
You don't have to comment.
Yeah, well, I'd say much like you, I'm on the, you're seeing I see the commercial impacts, right? But not just the government shutdown now. I think there's, in the past, year or so, we've just seen reduced science funding in general, which we see as a manufacturer. Now, thankfully as a corporation, kind of, I guess, not so great as an individual, but the defense, because of all the uncertainty in the world, there's a lot of increased defense expenditures. So that's caused a bit of a shift in kind of our focus in the past, a bit.
For sure. Any other questions?
One quick one,
All right.
mainly a comment about IUs, Integrated Ocean Observing Systems, and the role of the regional associations, NERACOOS and MARICOOS, in handling immense amount of data and making it available for policymakers, stakeholders, and general public.
Yeah, the ICE is great. I think when we're talking about data standardization, there's actually a big effort among the ocean observing stations to standardize data, to standardize metadata, the data that's about the data, even collecting things as basic as contact information for who has collected data sometimes isn't there and available. So just making sure that all those basic fields are filled out. Regionally, that's really important, and it's a really important ongoing effort.
Anybody else? All right, thank you.
You're welcome. Thank you for your time. I'm happy to answer any more questions.
Great.
Thank you. It's great to meet you.